So thank you, ladies and gentlemen. Tim will give me the chance here to share with you some of the use case that we work with quite a few companies, from telecoms companies all the way to hospitals, to even banks. They use some of these solutions to do the automated testing. So let me just give you a brief outline about myself. I'm Christopher here, where I've created this product called Glymatic, where actually allow you to do automation as well, although you've been done a lot in office automations. And I have 15 years of running company. I started AI in as early about 10 years ago, where we start doing AI in manufacturing systems. Yeah, so let me give you, I think the front speaker have talked a lot about the challenges, about time, a lot of the process that you do, right? Even you do scripting, right? You still need human to do the script, right? So that's something that's very painful. And especially when you do regression testings, right? Where the process or the software change and you need to continue to maintain the script. And then a lot of time, right, it's like, they always don't have time, right, because they always have this continued release. And a lot and testings are always allocated very, very little time. So with very, very little time, these are a lot of the common challenge. Although we have talked about automation, but to be very frank, the existing automations that we have, whether using Seleniums or you're using some of these RPA tools, right, you still need to write, or you need to at least click and drop the box. So the key thing lies here is that can we move beyond that? Can we actually kind of that, even when there are changes in the software will be able to test for you without actually breaking your script. And yet we know that it's actually in the right kind of results. The other areas that which I would like to highlight here about testing is that when you cross from a legacy systems to a web-based system to a mobile systems, and then you have to, and on top of the testing the functionality, right? We are looking at testing also the GUI. That means that, for example, is there any kind of, is the logo appearing correctly? And if you have to print something out, like convert some of this document to a PDF or to an image, are the data in the image coming out correctly? So sometimes the data, the conversion could be the conversion problem. Sometimes could be the backend engine generating the wrong scripts, the server error. So we would really need to do a lot of these things, and a lot of these things that is actually in generate into a PDF or image, or even checking whether the screen elements appeared correctly, whether the colors are appeared, or even whether the text overflow, especially when different mobile phone, different screen resolutions, where the screen actually kind of different due to different resolution, the text is overlaying on top of the images, or the text are being cut off. And how do you know that? Because at the moment, right, a lot of the testing without AI just cannot do that. And this is some of the very kind of common challenges. Later, what I will do is that I will show you video, explain in the video, right, how we actually solve this kind of problem. Okay, so as what I say, that the existing thing, we're still talking about scripting, which means programming. And then we have to use human eyeball to check, and that is not consistent. You can't get people to work 24/7 when you roll out the product in the next few days. And of course, we'll talk about outsourcing, but again, all these are costs. So can we run all this in a more cost-effective manner? And what we bring in is that we bring in this called RPA with AI. We call it cognitive automations. And actually, how does all this work? Right? I think the front speaker have talked a bit about how the AI can benefit, cut down times, reduce mistakes, as well as to do prediction. Later I'll show you how actually the AI do prediction. Okay, so I think this is something that a lot of test engineers have come to me. How do actually the AI actually predict and know that this is something, and how does it? What do you mean by learning? What do you mean by training? So later I will actually run through a simple illustration about how that works. So, but I give you a high level thing about why the RPA come into the testing area. I think the key thing lies here is that the RPA is actually, it evolved, I would say that some part from a testing tool, but it moved beyond that. It moved beyond that in a way that is mainly no code. That means that it makes your job easier. You don't really have to learn a new language. It's kind of click and drop. And another area is that when you combine the AI, that's where it give you a lot more kind of a boost in terms of the testing, because even when the environment change, the AI will adapt. Okay, and how do we know adapt correctly? Later I'll explain to you how we actually adapt correctly. And this is something where in the past, right? Even when, let's say, you're doing a web web testing, if the element change, the class change, you have a problem, because, and you really need to see that, is it because, especially when we have what is called dynamics web pages, where the elements are generated on the fly, and although you can use those XPath, but even that, sometimes even the path will change. But how do you actually handle that? And this is the things where that when we come with the AI, it can do more than just even where there are changes, where a human can figure out. You would think that anything looks similar, you will actually be able to click and actually push through for you. So what can generally the RPA or AI do is that there's a few different in terms of the technologies, in terms of the traditional testing tools. Generally, the newer type of RPA or AI tools, right, we're really not looking so much at the internal code anymore. It also saves a lot of learning time, because if you want to actually test a web page, even using Selenium, right, you really need to go and understand the element. You need to go and view the source code and the HTML code and find out where's element of class and figure out whether that element can be picked up. But the new type we're looking at is actually totally mimicking what humans are doing by looking at the screen using what is called image recognition. So image recognition is our AI, and with that, right, actually simplified a lot of the things. It speed up the speed of the deployment, and it also allowed the system to change, even where the color change, the sizing of the image change, whatever, the AI tool will be able to capture it and click through it itself. The other area is actually when we come to huge testing, like decision makings, or even I talk about where we have all the different type of software that you actually need to run through, right? This is where this AI, where it's actually screen-based, image-based, right, are easily accessible to any system, including virtualized machine. Sometimes we are, as a third-party testing house, right, you may not be able to install anything on the software that you are actually tested on. You may be doing remote desktop. You're doing virtualizations, and they don't allow you to do that, and they expect human to do it. But we're using image recognitions, using the AI tool for computer vision, right? It being able to access all these. So we have customers where they have some, like for example, in the web, where it involve various types of image generated or various type of Java generated images, and they have problem when they come to accessing it through the normal older means, right? And they need to do a lot of JavaScripting, right? All this can be easily handled when we have the image, as well as being able to handle pop-up, understanding the content of the pop-up using what is called natural language processing like humans. So this is a huge change. Okay, the other area is that when you come to decision making, right? If you need to test, for examples like where the permutation become very high, I always say that if you have a simple field, a field that have, like say 10 field, and each field got 2 different combination, and it gives you different type of result that you need to test the calculations, right? It's going to be very difficult for you to write any if-else script. So you take you a long time to write it because it's for 10 field and two combination, and each field got two variable, maybe A, B for field 1 and field 2, C and D, right? It's going to give you a 10 to the power of 2 or combination. We're talking about 100. Imagine if I increase the combination to 10, we're talking about 10 to the power of 10. How are we going to test this 10 to the power of 10 and check that the calculated results are correct? Because probably people have taken many years to do it. But interestingly, the AI actually can do this testing very much easily by just creating the data in a data set and let the model learn, and it will actually predict the result for you and give you the answer. Yeah, so this is something that is very new, very interesting about how we actually build the data set and use it actually for testing. Later, I will show you some video how that can be done. Yeah, because people are always puzzled, right? We'll be talking about AI, all this. How does it actually work and does it really apply, okay, to the kind of scenario that we have? So the first thing is that I think most of the people have not really talked about what is artificial intelligence. So artificial intelligence is actually quite a big field. It's a field, and it actually have been around for about 20 years, but it's, and indeed we say that the AI actually got a winter period, right, where that, for a time where we actually give up on artificial intelligence. And I studied artificial intelligence early, about in the 1990s, so that was kind of time where we talk about a large part was actually on the expert systems, and we do a lot of regressions. And then after that, we move into what's called data mining. And after data mining, we realized that the algorithm that have been developed in actually data mining, or we can talk about different type of algorithms, right, can allow the machine to think and make decisions to close to what the human can do. So most of the time when you actually talk about AI, right, another part of AI, which I call it structured data machine learning, basically is that later I'll show you a demo. How do you predict that which module you need to test? Yeah. But before that, I want to introduce you what is called structured data machine learning, because actually all the machine, the computers, right, their intelligence are based on the input. And a lot of this input, right, we need to structure this input into what is called structured data. So what is structured data? So I'm going to show a very simple illustrations about how actually the machine learn and what is called structured data. Okay, so let me just show you a very simple you all can see my notepad, right? Hello? Yes. I don't know.
Yes, Christopher. Yes.
Okay, I'm going to illustrate how to actually the machine learn. I think this, because once you understand how the machine learn, right, then it's a very useful skills to have, because it will help you to select type of tools and start understanding what can and cannot be done. So a lot of people don't really explain how do the AI actually work, right? So how do the AI actually learn, and why do we need a training data? I'm going to explain in a very simple kind of a format of, let's say you have two axes, and one axis is called the y-axis. And the next axis, I call it the x-axis. I think everyone knows what is this, very simple. And I'm going to show you something like, if I would draw something here and I call this, I'll tell you the instruction beforehand. And I say that all these are stars, okay? And then after that, I would draw another box and I say that all these are rectangles. And now I want to ask you, right, if I will want you to divide this into two classes, one class is called star, one class is called rectangles, how can we do it? We can very simply do it using something like drawing a red color line like this, right? We can just draw a red color line and say that if I were to divide this thing into like y equals to x, that means that whenever y increase, the x increase at the same amount, and this is a function. And I write a very simple function here called this is y equals to x. Okay, and this is the line. And now once I have this line, right? And now what is very simply is that if I don't give you anything, I delete all this. Okay, once I get this function, and I were to put here a new shape like this. Okay, I don't use the same color. I put a new shape like this. And you can easily tell me that this belongs to the star category because it falls onto the left side of the x equals to y formula. And how do we know? So actually what the AI do here is that basically is actually teaching the AI to draw this line called x equals to. So how does it draw it? It draw this line based on just now the data set that we have. Okay, the data set that we have, the star and the rectangle. And this is how the AI built. And this x equals to y, basically we call it a machine learning model. Okay, this is called a model, and this is called training data. Okay, this is called the training data. And since we already label this data called star and rectangle, we'll call this supervised machine learning because we already got this data. So there is another type where we thought non-supervised machine learning, not very often used, but we do use it a lot sometimes when we want to look at abnormality because we don't have the data set. That is when we have everything that look the same. Okay, we don't really know, we don't really label them, but we know that they cluster together in one location. And we can let the machine draw this thing into a cluster, we call this unsupervised machine learning. So with this understanding of what is called machine learning, I hope this simple illustration give you an idea that basically the machine learning, as I repeat again, is just to draw this line, okay, to create this line for you. It can be a straight line or it can be a curved line, depend on the function. And there are ways we call normalizing the data in a way that we can draw this line that become a straight line and make it easy. And this is example of what is called a machine learning. Okay, so what we do here in the machine learning, later I will show you another example, is that a lot of this data will actually go into numbers, and from the number itself, right, then we can actually start predicting, because all these points here, the star here is basically a number, x and y coordinate. Okay, it's a number, so we call this one set of number, and from here we can find the pattern. Okay, with that, I go back to this thing called structured machine learning. So I hope I give you an understanding of what is called machine learning. And once we have this concept of machine learning, right, how do we do it in image when image doesn't have a number? Okay, and but that's not true. Image actually got a number. Every pixel, there's a number 0 to 255 for what is called gray color. But if you have actually 3 color, we're called RGB, and there are 3 metrics of RGB. And for natural language, what we need to do is we call what is called language embedding. How do we embed the language so that it become a number? There are many ways. I don't have time to go through that, but I just give you an understanding that basically all the machine learning, right, to build a machine learning model, right, you need to have data to create. Just now I show you the x equals to y, that formula, that line. And once you have that line, that formula is just one small data we store. And every time we have new data, we just use that to calculate whether it's on the left side or the right side. That's all. Just to give you a concept of machine learning and how it actually works. Okay. So the thing like is that why do we want to use machine learning in software testing? Okay. The key thing lies here is that most of the things we program in the if, else, or scripting are very, very rigid, that it's not possible to program all the permutation. That's why I talked about the 10 to the power of 10, or in an image, right? Every pixel is kind of like 255, which is 1 to 255. How do you know that this really is something that match or don't match? And when we have a lot of dimension of the data, just now I show you X and Y dimension. But if I have a data point that involve, like, for example, who's the tester, what time he check in the code, what time he check out the code, how long he check in the code, how many lines of code does he write, in the line of code, how many we call branches or decision you make, how many variables, and I want to use that to predict, right? It's going to be very difficult to tell that whether this piece of code, right, is it going to be, do I need to spend more time testing or spend less time testing? So this is some things where that the AI can actually, based on historical kind of complexity of your code, the number of lines, could look at all these variables and then build a machine learning model based on the past data, and then predict that whenever someone checking the code, right, how much time should you spend testing the code and how much changes. Of course, there are new things that we look at using natural language processing, even to check whether the logic in the code is according to what we have actually put inside the specs. But that is even more complicated because you create a more training data. So when we talk about all these, right, when the AI can actually do all these kind of a prediction, it gives you more time. That's why it actually reduces the time and also reduce and increase the reliability, as just talk about that. If the image slightly change, later I'll show you that, where GUI change, or even the element in whether in the mobile or Windows elements, or we talk about where element change, that the AI will be able to figure out this is the right words and is still going able to go through and replace the right words for you. And that's where the NLP come in. So this is where we talk about how the testing can be more reliable, because just because you change the element without changing the function, it doesn't break your test script. This is where the AI comes in. And the other area we talk about maximum test coverage, because now with the AI, we can test a lot of permutation without writing any code. The AI will just call out all the permutation for you. Of course, there are new ways, even we can allow the AI to generate all the different type of permutation. So this is where later I'll talk about how the test can be prioritized by using AI to predict which one got code, and that will help you to reduce the time to market. Okay, so where do we use the AI? So I say that if you have a simple test case, maybe you don't really need to use AI. The AI comes in only when you have a lot of modules, and the modules got a lot of complex decision makings and a lot of branches. And this is one the AI to actually build a model, because you need to create the training data first. Creating training data, there's also a time expenses. We need to take that into account. The other area is that when we talk about priority, when you use the AI, because if you only have a few modules, you may not need to actually kind of prioritize. But if you have 1,000 to 2,000 modules, you have a lot of software engineer checking in the module, you want to prioritize which one to test first. This way you need to build a priority matrix, and then can use the AI to actually kind of predict which module high chance there's a defect, and you test that module first. And the other thing is that AI will come in when you want to do, like, for example, I talk about data extraction. Why do data extractions? For example, the output can go into an image, can go to a PDF, or you want to see that the data on the screen, they say text overflow. You want to look at the visual element, visual inspection. And this is where data extraction and visual element inspection come in very, very important with AI. With customer want to test whether the color are correct, or they are putting in the right images coming out or not. Okay, then let me, so these are the things. I think I won't go through a lot of this. I think the previous speaker had talked about how all this kind of testing, how much cost saving that you have. But generally, I would say that AI are used for testing with the visual elements, and we can use that to predict software defects. And we can use prescriptive software testing to actually look at things that is abnormal. Okay, and this is just now I talk about supervised and what is called unsupervised machine learning. Okay, with all these things, I think if a picture tell 1,000 words, a video will tell a lot of things. So I'm going to show you an example of a visual element testing that what our client face and the problem they have. Okay, what is happening here is that we have this client. Here we actually simplify a lot of things. We actually have the what is called the visual, because of some of the software that our client design, right? They will have the visual element design beforehand using Figma to design all the different elements. So this is example of, like, they have designed all the buttons, like the OK buttons, already like for all, this is actually for all the pop-ups, right? So if you to use the traditional way of doing software testings, right? Basically, you need to go and find the elements in the backend, and then you need to code it. And every time I go to a different screen, there are different type of pop-up. You need to actually go and find the element and then find it and then click it. But if you're using the AI, right, basically what you need to do is actually that once you get the we call the prototype of the mockup, you can start writing the script even before the software are made, because you already got the visual elements. And a lot of software, usually we have what is called the UX UI designer will design the visual elements. So our client want to do this before even the software are being developed, so that they have time, and also when there are changes, right, they don't really need to do anything, because even the software change the slide of the thing, the AI will recognize the element to look at is actually the OK button. So here what we're going to show you is that when the AI actually run, right, what it do is actually you're going to click all the OK element over here, and irrespective of the location. So, and irrespective of the size. So this is when you run, the AI will be able to click different type of element, and it's just one step because it's all trained inside what is called a machine learning model. Yeah, so you can see over here, we put this on the image here just to show that you actually click. This actually, we did this video just to show our for this event, to show you how we actually will be okay. Because in real life, it doesn't work that we have to run it from start to end. But you cannot show the thing, because over here, what we are showing you is that it only take one steps to build a script to click all the different OK. And if every step that is this thing, you can just write one line. So you see the power of AI, right? Instead of writing like say just now there about 8 type of element, you need to go and find the AI element, right? You just write one line, and you just need to train this AI model, which take, let's say, 5 to 10 minutes to do it, which a layperson can just draw boxes, and straight you will be able to click through for you. So even if the OK button change a bit with different color, different back-end elements, whether it's a mobile or whether it's actually a web, it doesn't matter. Whether the resolution change, it doesn't matter, because the AI will figure out and actually click through for you. So this is the power of why the AI can save you a lot of time, because this one, when I show my customer, they say, wow, this is what it's called dynamic, and it doesn't even depend on location. It doesn't have to look at the surrounding element, because you actually figure out it by itself. Okay, so I hope I give you a good understanding of all this. And we have customers who want to check color. So color is not possible to check, right? Because you write if you look at the back end element, everything is correct, but we want to check color. So over here, we want to detect the different type of color. You can see that the system actually show 2 color, the blue color showing up the dot. And then we want to detect that these are actually the color, and the size of the item with the right color actually come out with the boxing, right, in the right type of sizing. So we can check the color, we can check that the sizing of the elements are within the range, the tolerant range of what you want. The logo appeared correctly, because sometimes people put the wrong logo, wrong color, or whatever. We can do all this checking. This is where the AI actually can do a lot of all this checking and testing itself. So I don't have a lot of time. I think I won't run through the video. Okay. People have been asking me, right, how do you actually know, how does prediction work in the AI, right? So the AI, again, I need to highlight here, you need to feed data. The AI is not something that you will do magic, it's no God. It's something that you really need to put in data to train the model. So how do we actually train the model, right? It's something that is a lot of people always ask me, right? And what I'm going to show you is, okay, I want to show you that basically, it's right, you need to create what is called features before a machine can learn. So here I give you some examples of features that what we do here when we actually work with customers, right? By the way, these features, it may or may not apply. We look at what is called the line of code. First, even the number of blanks, right? Lines of blanks, we take that as a feature. That means there's a dimension we count. We also look at the branching count, how many times it branched to different decision making, how many pairs does it call. We also look at we call silo matrix complexity. Okay, basically it's a complexity when you write if else, how many times have you nested inside. If you are writing in Java or writing in Python, that they are actually a kind of software that allow you to generate all these complexities. So what we do is that we do, but for this illustration, right, I just want to show you that we actually put all these. Then we also talk about decision density. That means that within a line of code, 5 line or 10 line of code, how many decisions are being made. So all this complexity, we find that it actually help us to predict, when there are more, but how much more? That's the question, right? Even I give you the value that this code is more complex, these code are less complex. But of course, this thing can only work for these things that you have access to the source code. If you don't have the access to source code, it's not possible. So this one is a kind of we access the source code, and then we run all these calculation for every module that's been checked in. After we do all these things, like we actually have the past data of who is the developer, when he checking, how much time does he make and how much changes he make, right? And at which side of the module, and all this calculation, we will build a machine learning model. Okay, because this model, to build this model, right, it's no way when we have, let's say, 1,000, 2,000 module and we're different time checking in, there's no way we can actually use our I or max to calculate. We let the machine figure out, but just now I show you example, and you actually create the rules. And once you create the rules, right, this is example how the data look like, right, in so many numbers, right, actually make you having a headache, right? Can you imagine? This is the number of, this is an example of a data set that we use to let the machine learn. So you can see that this is below are all the module checking it at different time. And based on the module checking time at different developer, different divisions, and which functions, right? We look at the historical data, and then we see that if this is the historical data that this person, based on this complexity, have more bugs, right? This is where we can actually use that to build a model to test. And this model is automatic built by the machine using what is called AI algorithm. So this example of how we actually deploy this with the client. But of course, before we deploy, we need to build the model. And once we build a model, we can auto deploy it. And this example, how we run it, this is the output. When we run it, actually, we don't run it by reading it in Excel, be very frank. It's just that I want to show you that basically we need to read every data point of this module. Let's say I have a new module, the module generate all these parameters. And from these parameters itself, right, we will actually then predict the output of this module, whether there's a high chance the defect or no defect, and what is the probability. And the probability is very important, whether it's close to model or not close to our model. And this is a way for us to prioritize that. If there's a defect is yes, and probability is very, very high, this is how we actually prioritize the module for actually testing itself. Okay. So I see another video. This is where we talk about end-to-end testing, where we have things that come out in paper document, like paper, in a PDF, and we can use the AI to extract out the data and test whether the figure is according to what we want. Okay, I don't have a lot of time. I just skip a bit of this. Okay, and I use this to test layout. Okay, where we want to see the text overflow. This is actually a mobile. So what we do here is that in the mobile, right, we test this and we actually print screen. We extract the screen out, print screen. And after we do the print screen, right, we want to know the text area. Okay, the text, how much overflowing is the text in this area. So we're talking about the text overflowing. Okay, and whether all the text, because some of these got dot, right? Some of them they want to check with different dimension, different sizing, right? How will the overflow be like? So here we want to test that. So how do we test that, right? We test that. Once we test this, we extract the data into a structured format like in the Excel, and then we can test the text that whether how much overflowing are there inside the things itself. Okay, so let me clear everything. So this is where we have where we pull out the text and we check that all these numbers that we want, especially on some of different devices, different dimension, we can test it and pull out everything is correct. Okay, so this is an example of what is called where you test the overflowing of text and all this stuff. Okay, and by the way, this is in different language. Okay, so this annotation to clear all the things. So we have done this for legacy systems and some of this cost saving itself for the banks where FT required. Okay, so okay, before I'm left only about 5 minutes, right? So the key thing lies here is that first of all, before you deploy AI, right? As what I say is that you really need to understand that first, any AI, I always tell people is that you need to know when is your deadline of the project, right? And you need to invest time to build the data set, to train the images and all these things. So you really need to understand what are you trying to test and whether AI is something suitable or not. So you need to look at latency, the speed, and also the time you have, or whether there's alternative, whether you want to use the traditional AI or you wanted traditional scripting or you want to use AI, because AI also, as well, I say that there's time involved in, and AI is usually very useful in regression testing because you keep repeating test the thing. So the effort changing, and then once you train the AI allow you to kind of be more reliable, instead of breaking your script when there's small changes, when there's no bug but small changes in the software. So really need to look at the time, resources, and the skills, and also you really need some skills about how to tune the AI. This is something takes some experience. It's good and bad. I wouldn't say AI is not the best in everything, right? A lot of people are pushing for that, but you must understand you need to invest time and you need to know how to adjust. If you are trying to build a predictive machine learning model, you really need the skill set. How do you tune the AI model? And whether the accuracy of the model worth the time. So let's say you already got 5 or 6 modules, there's no reason, but if you have thousands and thousands of modules and need to prioritize what to test and do predictive analytics, then you really need to build, then that's advantage, right? Because you allow you to rule out with certain risk level. Okay, then of course, we talk about volume, right? I say that if you only need to test this one time, and maybe it's not worth the effort to build the AI model. Maybe even sometimes I tell people, right, if you only need to test it one time, maybe you just get a human to do it, right? You'll be cheaper and faster. But if you need to do regressive testings, and then you need to test it, especially there are some changes as the customer like to make some changes or department make some changes, and when you test overnight, right, this is where the AI come in because it's more reliable. It runs through faster, better, and let you detect what to test. So overall, I always say that AI is a technology, it's a tool. Whether it's not to apply just because it's a fancy word, right? It's ultimately whether you really need it. We have clients really need it because, as I say, we work with telecom, where they roll out their own application. They will test all the device farm. The device farm got all different resolution. They want to test start to end. And now they're incurring a lot of resources because this application they have will keep different revision and keep having different update. But generally, the GUI don't change a lot. And the AI will be able to cope with that. Okay. So I have about 2 minutes. So generally, against any project, you need to ask these questions. Who's going to benefit? What's the outcome? What's the result? Where, when, how, and why? So I think this is quite a generic things that I always ask people to do all this. Consider that testing automation is also the testing tools that you really look at, and of course, work out a high-level cost-benefit analysis before you really embark on the AI. Sometimes the old way still works, but AI do have the advantage. So over here, I hope that with this event, I give you a broader perspective how the AI works. Usually what it's used for, like a lot of visual elements, predictive, and of course, checking layout and all this stuff. These are very good things, and also how we make it more reliable. I think I have about exactly about 14 minutes, right? So I probably stop here. So maybe I can go to questions.